On the notes sheet with the practice set problems, we're going to work through at first numbers 1 through 18, and then the next video will cover numbers 19 through 40. So for number 1, we have 10 to the power of n is equal to 6. So we need to isolate the exponential, which in this case it already is, and then we rewrite it as a logarithm. So log base 10 of 6 is equal to n. And once you're at this point, you're going to let the calculator do all the work for you. So you just type it into the calculator using your log base or the common log that you've been given. And remember, I told you need to round off to 4 decimal places. And on your note sheet, it says round to the nearest 10,000th. That's what 10,000th means. It's the 4th decimal place. So n is equal to 0.7782. Okay, for number 3, we have 9 raised to the negative 10 x power is equal to 69. So the same thing, I isolate the exponential, which is already isolated, and we take the logarithm of both sides. So I have log base 9 of 69 is equal to negative 10 times x, and so I have x is equal to log base 9 of 69 is equal to negative 10. And so when I type all of that away into my calculator, this is going to give me x is equal to negative 0.1927. For number 5, we have 18 raised to the 9 minus 5n power is equal to 35. So again, our exponential has been isolated for us already, so we rewrite as a logarithm. So we have log base 18 of 35 is equal to 9 minus 5n. So I'm going to subtract 9. So I have negative 5n is equal to log base 18 of 35 minus 9. And then I divide both sides by negative 5. So I have n is equal to log base 18 of 35 minus 9 divided by negative 5. So that means n is going to be equal to, we plug away into our calculator and we let it do all the work for us, making sure that when I put the log base 18 of 35 minus 9 in, I hit enter before I divide by the negative 5. You either do that or you have to use parentheses as your grouping symbols. So this gives me 1.5554. I'm sorry, just 1.554. So one of my 5's is not there. Moving on to number 7, they get a little more complex because it's not always going to be as neat and clean as your exponential already being isolated. So in number 7, we have 3 times 13 to the power of r is equal to 26. Now, the most common mistake that students make is they want to multiply this 3 and 13 together, but you can't do that because the 13 has an exponent of r and the 3 does not. So the only way that I can get rid of this 3 so that I can isolate the exponential is to divide both sides by 3. So this is going to give me 13 to the power of r is equal to 26 over 3. Now, it's important that you keep everything as a fraction until the very end. You don't want to round off in the middle. So when I rewrite this as a logarithm, I have log base 13 of 26 over 3 is equal to r. And the parentheses were put there on purpose because when I put this into the calculator, I want to put that 26 over 3 in parentheses. Otherwise, it's not going to take the log base 13 of all of it. So I have log base 13 of 26 divided by 3. If I had just put the 26 in there, then it's not going to evaluate correctly. So from here, I just let the calculator do the work for me, and I round off to my 4 decimal places like I've been instructed. So R is going to be equal to 0.8419. For number 9, we have 17 to the power of 5b minus 4 equals 6. So I'm going to add 4 to both sides. This is 17 to the power of 5b is equal to 10. And then once I'm here, I'm going to rewrite as a logarithm. So I have log base 17 of 10 is equal to 5b. And to solve for b, I'm going to divide both sides by 5. So log base 17 of 10 divided by 5. And I just plug away. I let the calculator do all the work for me. And I have b is equal to 0.1625. For number 11, we have 4 times 11 raised to the power of 4 minus 6x equals 88. So the very first thing I need to do is I need to get rid of this 4, and I can't just multiply it by the 11. So I'm going to divide both sides by 4. And this is going to give me 11 to the 4 minus 6x power is equal to 22. Once I'm here, I rewrite as a logarithm. So I have log base 11 of 22 is equal to 4 minus 6x. So I need to solve for x at this point. So I'm going to subtract 4. So I have negative 6x is equal to log base 11 of 22 minus 4. And then I'm going to divide both sides by negative 6. So this is x is equal to log base 11 of 22 minus 4 divided by negative 6. So x is going to be equal to, by the magical power of our handy dandy calculator, 0.4518. For number 13, we have 6 times 2 to the power of x plus 5 equals 87. So this is a little more complex than the previous 3 in that you're going to have to do a couple of different operations before you get to the exponential by itself. So the first thing I'm going to do is I'm going to subtract my 5 from both sides. So this is 6 times 2 to the power of x is equal to 82. Now it's very important that you understand you cannot divide by the 6 before you subtract the 5. It won't work. And then once I'm here, I'm going to divide both sides by 6. So this is going to give me 2 to the power of x is equal to 82 over 6, which becomes 41 over 3 when I reduce it down a little bit. So once I'm here, I rewrite as a logarithm, just like before. Log base 2 of 41 over 3 is equal to x, and I let my calculator do all of the fancy legwork, and we end up with x is equal to 3.7726. For 15, we have negative 8 times base e to the power of negative 9p minus 7 is equal to negative 102. So we are going to first add 7 to both sides. So this is negative 8 times base e to the negative 9 times p power is equal to negative 102 plus 8 is going to give me negative 94. And then I'm going to divide both sides by negative 8, and this is going to give me 94. So I'm sorry, base e to the negative 9 times p power is equal to 94 over 8, which is going to reduce down to 47 over 2, and 47 over 4. double check that before we move forward. So 94 divided by 8, and